Hey chat, this is Sir Le. I'm here at the research laboratory. Hopefully my microphone is working this time around. And I'm just gonna teach you how to use an analytical balance. An analytical balance is an instrument that can measure very small amounts of mass. My goal in this video is to weigh enough glucose to make 100 ml of 0.01 molar solution. I've done some calculations and I need around 0.1802 grams. Now, if all of this sounds foreign to you, don't worry, we will have another video reviewing these basic concepts. For now, what's important to learn is how to use the analytical balance for measurement of mass. I've gone ahead and turned on this analytical balance around 2 hours ago. You cannot just simply plug in an analytical balance and use it directly. Think about it, if it's just turned on, the current inside of it isn't very stable yet, and the value readings that you will get will also fluctuate very widely. This process of turning on an instrument and waiting some time to pass before you use it is called warming up an instrument. This analytical balance has already been properly warmed up. Usually we wait around 15 minutes. It's been 2 hours, so it should be safe to go. If you could look at my calculation, this assumes that all 0.1802 grams will be glucose. So I need to weigh pure glucose. If you can imagine, if I weighed instead glucose that had salt or other types of solids inside of it, the final concentration of glucose will not be 0.01 molar because I was not weighing 0.1802 grams of glucose. That's why in the analytical chemistry laboratory, we need something called an analytical grade reagent. I have here analytical grade glucose, which I will use to create my solution. Of course, there are other chemicals that aren't as pure as analytical grade. We call those technical grade. So we use them for purposes not necessarily needing high amounts of precision. It's very important in analytical chemistry to be very certain about the values that we are dealing with and reporting. Can you imagine if I was off around 0.1% in the level of poison in food? It takes only very small amounts of chemical to cause very big problems. That's why in analytical chemistry, we want to be as certain as possible. When I say certainty, we want the highest accuracy and precision. This is also the reason why we are going to be using an analytical balance. Because it's sensitive to the 4th decimal place, it allows teachers, chemists, and students to measure chemicals at a very small value. Since chemicals are expensive, we don't want to use too much of them. But if we also use too little, it would be very hard to weigh. An analytical balance, in this case a semi-micro analytical balance, is just what we need. Watch me as I try to weigh 0.1802 grams. First, I will transfer out some glucose so that I could measure it. It's not advisable to just get your spoon or your spatula and dig in directly into the bottle. If this spatula or spoon was dirty, then the whole batch of analytical grade reagent is ruined. So we want to avoid any form of contamination. I'll shake the bottle first. Then I'll just transfer what I need into another container. It's from here that I will get my 0.1802 grams of glucose. Now, I'm going to turn down my voice because I'm going to start weighing. The analytical balance, because it is so sensitive, can detect any vibrations in the air or on the tabletop. So, when measuring, you need to be as careful and as quiet as possible. The first thing that I will do is to get another empty container to which I will transfer the solid that I will weigh. I'll put it inside the analytical balance, close the windows, and then I'll wait for the reading to stabilize. Okay, since we are now accurately measuring the mass of the container, we can go ahead and click Tare. Clicking Tare allows us to eliminate the measurement for the container, so that any glucose we will add will be the one measured in grams. After tairing, I am now ready to use the analytical balance to measure glucose. To do that, I need to open both sides of the analytical balance. I'm right-handed, so I'm using my spatula or spoon on my right hand. Using my other hand, I'm going to carry or lift the glucose. To put sample inside the container inside the analytical balance, I need to position myself so that the sample will be to the left, and then my other hand, which will transfer the sample, will be at the other end. When I reach the value that I desired, I close the windows once again so that the value will become stable once more. As you can see, the sides are closed and the reading is relatively stable at 0.1817 grams. It would have been lucky if I got exactly 0.1802 grams. However, in reality, we really don't need to be exact and perfect when it comes to measuring mass for solutions. Instead, I'm going to write this value down in my notebook and I'm going to calculate the new concentration instead of 0.1802 grams. I now have enough solid which I know accurately the mass of, which I could use to create my solution. I'll just simply open up the window, take the container, and use this solid for my preparation. I'll see you in the next video where I will be creating the solution using this solid.